I'm going to show two different ways to use connectors to create a fastener connection. The manual way is if we go to connectors, go to fastener, we'll go into the options here, and we're going to do link type as components. Our tolerance is going to be the distance that it's looking between the parts from the initial node that we pick. So we'll go ahead and pick our node. We'll pick it either on the blue part or the red part. It gives you the initial projection that it's found, verifying that indeed has found these two parts as a connection. And then what we need to do is create a new fastener control. So fastener, create, and for now we'll just do a bolt general, bolt C-bar. These are all going to be rigid spiders with 1Ds. You can look up the different realization types in the help. In here, you also have your min and max diameter dimensioning that it's going to locate the hole size for. Say OK, and assign our control, and go ahead and realize. We've got our wagon wheel, our 1D, and our wagon wheel, and we've created it there. So let's go ahead and delete this and do another method, and that would be creating attachments and then creating the connection between the attachments. So the attachment is first going to look for holes by a certain size, and we can say automatic, and that's just going to be based on components. So we can go ahead and pick our 3 components, and let's go ahead and create our attachment control. Create new. It's just going to be a rigid spider. We'll say OK. Assign it. And you can see here that it's found each side of that hole and realize it. That automatically finds the holes and creates a spider, but now we need to connect the 2 spiders, and that's called a connect. So we'll say connect. What you do is you actually now grab the spiders. We'll look at why that one didn't pick that for some reason. But we'll go and grab that one and say create new. And that's going to be the connector attachment. So now we can say OK, assign it, and that's going to go ahead and create that 1D. Okay, so I'll show you the final product, and then we'll show you how you got there. So we've got our quad seam connector at a 45-degree angle, and we've got quads on one side of the plate and quads on the other side of the plate. So if I undo this, you'll see what I started with. So 2 completely unmatched meshes. First thing we're going to do is going to go into the connectors browser, the connector ribbon, and we need to make something called a control. That's what creates or has all your connector information in it that you can reuse on different entities. So you can see that I've already got one made here, but we can start from scratch. So I can say right-click create, and it's going to be a seam weld. We can change the type. So in this case, we're using a quad, seam quad angled. Tolerance is going to be the distance between your parts. Pitch is going to be using the nodal pitch, or you can actually input a defined density. So I'm just going to use the nodes, and I want to keep my nodes that I'm using on the one part. And we've got the angle. And then we can come down here and we use what's called a quad transition using imprint. Essentially what that means is we're going to take the line of nodes that we're using as our input, imprint it onto our part within a tolerance, and then we'll do a quad transition off of that. And that's all we need to do. So we've got this control, connector control. And then we go into the connectors itself and we say connector, we'll do a line connector. We'll pick the line. That's our input. We'll pick our control, and we can say check mark for realize. And you can see here we've got our quads, we've got our seam quads, we've got our transition quads on both sides of the weld itself, and then we've got a remesh on both of our parts. And we can see all the information here as well. We can change it as needed. The link is going to be your two parts that are being connected. So you can always reuse these if the components get updated. In this video, we're gonna go over how to create a seam weld with solids between two solid plates. So first thing we're going to do is input the nodes along which our seam weld is going to go. Then we create a connector control. This connector control is going to be a type of penta MIG weld. And that's really all we have to do. Everything else we can see in the help the different types of configurations we have for the seam realization connector for penta MIG. So we're going to go ahead and assign our control and our connector, and you can see that it's made the pentas with RBE3 connections from each of the nodes to the face of the solid. If we do a find adjacent between each of the parts, you can verify that we do indeed have a equivalent weld from the penta to the RBE3 and then an adjacent element. So we've got the full seam weld created with pentas. In this first video, we're going to create a seam connector using the line connector tool, the manual option. So if we go into the line connector tool and we can pick our nodes as our input by path, and we can enable a preview. That's going to give us a nice visualization of what that node path is going to be before we finally commit to it. So before we even realize these connectors, they give us a representation or a preview of where they've found a connection point. Then we create this control manager with a type of rod, and we'll use retain nodes. This keeps the initial input nodes as one of the seed points. Hit OK, and you can see it's made the C-weld rod elements on creation. So that's right along the line there. And then we can go ahead and now we'll use the automatic feature. So this time we're going to use the lightning bolt next to the line icon. Our options are search distance and minimum length. That's pretty much it. We grab the components as our input. So in this case, our components are our input, and it does a projection or an imprint to determine those lines, where it finds a line intersection. So here we're going to do the same thing. We're going to select our connector. We can do that from the idle mode. It gives us a preview, and then we go and create our control manager, connector control manager. Hit create, go and pick our same type of realization for rod, and say OK. Assign the control and realize. And in this case, if it doesn't realize right away, or if we've done something where we've forgotten to assign, we can then, in the browser, go assign it and realize. So green is good. Green means realized. Yellow means undefined. It doesn't mean that it's failed. It just means that it's undefined. So these are the two ways that we can create this connector. So in this video, we're going to create a fastener connector through a long span, multiple layers, and differing element types. So our total span is from about that top to that bottom here is approximately 34. And our diameter is 2. And we've got a total of 1, 2, 3, 4 layers. So we'll go into the connector browser, go to fastener. I'm going to go to the advanced options. And I've already selected my tolerance, so I picked 35, which is a little bit larger than top to bottom. I'm going to set my number of layers to any. That way it's going to allow us the ability to add in any of these different components. Link type is components. All my elements, all my components are displayed right now, so it doesn't matter whether I do display it or all. So that should all be good. I can click my node. And here you can kind of see it's starting to do a pre selection or a pre view of each of these parts that it's found in that connection. And we're going to create our control. So create new, fastener create. Let's use that bolt B31. Tolerance, we'll set the same as that 35. And our minimum dimension 0 and our maximum dimension 20 with his diameter based, which is well within our tolerance. And I can say OK, and then go ahead and apply that. Now when I go say realize, it goes ahead and creates the kinematic coupling between all of the parts. In this case, but for the solids, it's using all the interior nodes as well and creating the independent at the center, and then each of the interfaces. And it includes a washer layer for the shell-based one. We can go into the connector browser here and verify that we've got our 4 links. And we can see each of the entity names here: top plate, long solid, bottom plate, small solid. So it's picked the 4 links and created all of the necessary FE entities for this connector configuration.